Go on.
Yep. Okay. So yeah, so I'm Charlie Zhang, and digital asset technology lead at FinFabrik, and then I was studying in Beijing Tsinghua University and the University of Edinburgh. So you can connect me on the LinkedIn here, the URL. So that's just a quick intro of myself. Then I will start tonight's Meetup talks. So tonight's talk about the decentralized identity, through Hyperledger Indy. So before dive into the Hyperledger Indy, I would like to give some quick talks about the identity itself. So the identity, we have identity problems for individuals. We have too many login identities to remember and manage. The identities are fragmented and duplicated. Also, it's not portable and easy to access. The identity vulnerable to being stolen, faked, lost, or altered. Yeah. And also, sometimes we reveal too much information, too much privacy necessarily needed. And also the identity are not interoperable. So because of the time constraint, I won't go through every items. If you have any questions, then you can contact me later, or you can read the reference I gave in the talk by yourself. So this is kind of like the identity problems for individuals, and we also have identity problems for institutions. For example, they have to repeatedly and manually to do the user identity checks. For example, for opening a bank account or register a user account on their systems. And usually the institutions are victim of the identity fraud and phishing. And also they will spend a lot of money on some sort of IAM system development and maintenance. Also spend money on the cost of the user password security protection. And also they have the regulatory compliance to abide by, for identity checking, especially for the for some adult content or like selling alcohol, something like that. So those are the problems for individuals and institutions. And then if you look at the whole market size, those are the data in 2016. We have the smartphone users globally 2.1 billion, and estimate to in this year we have 2.87 billion mobile users. And then the global KYCS spending in 2016 reached 500 million and 12 million mobile banking users in US 2016. So that's the huge market for the applications to use the identity, because like nowadays people using the mobile, and then they prefer to have the either you have some all the apps there to log in, so you use your identity to log in, or you actually save your identity locally in the mobile. So there's a huge market for the identity application or identity systems. So in order to implement the identity system or application properly, in 2005, the Kim Cameron, he was the Microsoft chief identity architect. He listed 7 laws of identities. So I write down his identity web log at the bottom of the slide. You can read that later. So I won't go through all the items listed here. But the important ones are user control and consent. So you have one crucial important is that's a self-sovereign identity. So you have your total control and of your own identities. and the second one, the minimal disclosure for constrained use. You don't want to review too much of your privacies there. So those are the items when people to build a proper identity system or applications. Those are the laws or the rules need to bear in mind. Then come up another one is the that's another guy called Dev Burst. So Dev is an expert in the digital finance. So he wrote a blog named the putting identity on the blockchain. So he kind of had this conception or idea of 3 domain identity. For a normal user, you have your modern identity. Then from your kind of daily real identity, you can have your digital identity. Think about blockchain, the private public keys. Those are the digital identities like Bitcoin, Bitcoin address. Then linked with the digital identity, he called the virtual identity. Because each virtual, you can have different. For one person, you can have different virtual identities for different purpose, which each of these virtual identities are actually controlled by the digital identity, which is the private keys, and then the keys are owned or held by the real user. So you have the linkage of those 3 identities, and then you use the virtual identities for web login, for payment purpose, or for ID proof. So you can have different virtual identities, and then those digital identities and the virtual identities are actually can be stored in your identity wallet. And can be stored on the blockchain as well. So that's the conception of the 3 domain identity. And then later on, I will come back to this, how we use this in our current CrossPool system. So then that's quick intro about the issues, problem with identity, and how people come up with solutions to have a proper self-controlled decentralized identity. Now we come up for the next topic, the Hyperledger Indy. So Indy is one of the projects under the Hyperledger Foundation. So it's a solution based on the blockchain. So it provides the tools, libraries, and then reusable components for people to implement the identity application or identity solutions based on the blockchain. So you don't need to reinvent the wheel yourself. There's a lot of components and tools standards you can use. So on the bottom of the slides, there's the link of the project itself, Hyperledger Indy, and then the project Indy itself is actually contributed by the Sovereign Foundation. So currently you can go to the sovereign.org category use cases to view all the current user cases. I picked 2 of them. The first one, the Verifiable Organizations Network VON, it's an open source collaboration initiated by the governments of British Columbia, Ontario, and Canada. To put the company registrations, permits, and licenses on the blockchain. So that's a solution for that. And then there's another use case, CU Ledger. CU Ledger is a consortium of the US credit unions. So they use Hyperledger Indy to enable sovereign identity for their members. To prevent call center fraud and the identity checks. Those identity checks are stored on the sovereign network. I will talk a little bit of the sovereign network later. Yeah. So then around the Hyperledger Indy, one crucial part or one crucial conception is called the verifiable credentials ecosystem. So in this verifiable credential ecosystem, there are three main roles or main players. So the issuer, the holder, and then the verifier. So the issuers, they sign the credential and then issue the credentials, which is zero knowledge credential to the holder. So then the holder countersign the credential and save the credential issued by the issuers in their identity wallet. And then when the credential needed or required by the verifier, then the holder present the credential, which is a zero knowledge proof to the verifier, and then the verifier verify the authenticities of the signatures of those credentials. So that's how the interactions among the issuer holders and the verifier. And all these interactions are actually around the decentralized identifier, shortened by DID. So DID is those issuers, holders, verifiers, they all have their own DIDs, and then the DIDs and also the necessary kind of data around the credential are saved on the blockchain, the public blockchain, or a consortium or private, decentralized network as well. So that's how the relationships of the verifiable credentials. Then there's the main components in that verifiable credentials or in the Hyperledger Indy implementation. So from the left, the most the crucial one, the decentralized identifiers, the DID. So you can read the description of that, or I won't read that. And then the next one is the verifiable credentials. It's the same as like a piece of digital data, which you can save, anywhere, either in your mobile or in your computer, and then you can present that verifiable credential actually offline to a verifier to verify the credential. And then the third one, third component, they call the agents. So the agents themselves, a kind of P2P connection with each other to transfer, to share the credentials or issue the credentials. The communication between themselves are using a standard, or I will mention that later. For the standard to communicate between the agents. And then the last one, they distribute the ledger. So the ledger itself, the Hyperledger Indy ledger itself. And then actually only 4 pieces of data are stored or saved on the distributed ledger, on the Indy ledger. It's not the same as the Ethereum or Bitcoin. So the only data saved on the Hyperledger Indy are those four items I will show here. So the first one is the public DIDs. So for each of identity used or can be kind of issued the credentials, they need to have a DID. So that piece of data is on-chain on the Indy ledger. The next one is the schema. So the schema is like a metadata about a credential. I can show you the actual data later in the next slide. So then after the schema is to act as a metadata shared publicly. And then for each individual credential the issuer wants to issue, they need to create credential definitions. So the definition is a specific kind of object or description about the schema or specific implementation of the schema. And then the last one is the revocation registry, where it's used as a how to say, is a factor, or as a piece of data on the blockchain which can be used to check if the current credential is still valid or not, or has been revoked. So those 4 pieces of data are actually saved on the Hyperledger Indy itself. All the other data, like the credential itself, the data are actually off-chain. So to preserve or protect the privacy. So the data are not shared on the ledger. And then, so this slide, this will give you a JSON data example of the schema and then the credential definition. So on the top, as a JSON data for the schema, you can see the red line highlighted are the attributes names. So you can have, you can define a schema for a credential requires the last name, first name, your birth date, and etc. So those are the attributes. You define those attributes in the schema, and then the schema is saved on the Hyperledger blockchain. And then you, as an issuer, so as you want to issue a credential, then you need to create a credential definition. So the credential definition is a specific case for the schema. So you see the red line highlighted for the schema ID there. So that's the definition needs to be linked with a metadata of the the schema. And then the arrow pointed are the DIDs. Those are the format of the DID. Looks like a Bitcoin address. So that's the public key actually. So those are the data for the schema and public DID and then the credential definition. Those data are saved on the Hyperledger Indy ledger. And then in how those verifiable credential workflow works. So we start from a person in the middle. So that person, you normally will have some identity trace, like your name, your job title, your physical appearance. Then if you want to say, I want to have a credential issued to me, then you go to an institution or a company. So you give for example, a bank, then you give your identity documents to them. And then the institution will examine due diligence, KYC, to check the documents you provide to them are correct and true info. And then the institutions, then they can have a different template. Here we call the claim, or the template itself actually are the credential definition we described here in the previous slide. So those are the claims. You have different claims such as ID card or insurance policy or passport, something like that. Then for each of those claims, the issuer can generate and issue the different credentials to the users, and give the credential back to the user, and then the user will hold all those credentials by themselves, saved in their in their mobile wallet or somewhere. Then come up to the left bottom for the verification process. When the user need to present, or when there another institution requires the user to present a credential or do an identity check, then the user can pick the issued credential from their wallet and give it to the institution, to another institution, and then the institution can verify that. So those are the the workflow or the interactions among the issuers, the holder, and then the verifier. This is kind of this one is another example of the verifiable credential workflow for kind of multiple parties. For example, you can use different DID. So as a user, remember the 3 domain the identity model I introduced in the previous slide. you can have one user, then you can have different DIDs for different purpose. So in this case, you can have a DID X. You use that to go to your universities to ask them to issue a diploma credential, the Indy credential to you using DID X. Then you will have that. Then the school will check your real paper documents and then to verify that and create the credential definition schema and save on the Indy network and issue the real credential. After you got the credential, then you say, okay, I need to use the credential to apply a job. Then you go to the company, the new company, and then, but then you can use another DID, DID Y. You don't necessarily need to use the DID X, because the data you expose to school might not be the same as you're going to expose to the company. So then you can have a DID Y, and then use that to go to the company, and also you can present your diploma credential to the company, saying, hey, here is my my diploma. I graduated from a university to prove that. Then the company can verify, use the Indy verification purpose to verify that. Go to the Indy network and say, okay, that's diploma credential is true. Then the company can create an employee credential the definition on the Indy network and issue an employee credential to the user. You can save that in your mobile, and then vice versa. Then the user can use another DID, present the employee credential to a bank to apply for a loan. Saying I'm working for a big company. I need a loan, a mortgage, something like that. Then to verify my employee credential. So that's kind of like the multi-party credential issuing verification purpose. So from now, I will give you a little bit introduction of our system. So we built called the CrossPool. So CrossPool is digital asset issuance trading managing platform. So it's a suite of software to enable the issuers to issue tokens backed by a specific asset, and then they can use the solution for their existing users or investors to invest to buy their asset. In our model. You see the similarity of the three domain identity model. So you, as a user, you log in onto the system. You have a user account. Then for each the user, then you can create multiple DIDs using the private key, public key cryptography. Then move into different asset. Different asset could be company shares, or could be commodities like the gold bars, or could be like art paintings. Then for each different asset issuers, then they could create different Indy schema, Indy credential definition, and then they create those definitions. Then the user, the investor, they come in, they log into the system. Then they go to the different issuers, and then they're asking for them to issue the KYC credentials, because like for the such thing like the digital asset investment or STO, you need to be compliant with the KYC rules, AML rules. Then the issuer needs to give permission for the investors to be able to invest in their assets. So in this case, we use the Hyperledger Indy, the schema, credential definition, and credentials to do the KYC. To do the issues of KYC. After the investor got the KYC credential issued by a specific issuer, then they can invest in the specific asset. And also there's another usage for the private key, public key cryptography as a kind of a sending signature tools to sign the recording contract. So when as investor A wants to sell the asset to investor B, then they could use their own private key to sign the contract for the transfer transaction of the underlying asset. So here is just a high-level kind of architecture overview of our CrossPool system. We have two main modules. In the middle, we call the CrossPool base, and then the circle, the left and right circle, we call the CrossPool client. It holds the Indy connections to a Indy network, and also our system connecting to the author recorder DLT or blockchain network as well for the token transaction. So each of these CrossPool client will have their own user base, user management system. They issue different assets based on the issuer's requirements. And then once the token issued, then once the investor got the token, they want to transfer, do a trade with another user, then the the token and then the credential, the KYC credential I mentioned in the previous slide, will send to the CrossPool base first. Then the credential, the KYC, will be sent and verified by the CrossPool base, depending on the Hyperledger Indy network to verify the authenticity of the credential. Once it's verified, then the CrossPool base will release the token from an escrow account inside the CrossPool system. So to another user on another CrossPool client or on the same client. So this is how CrossPool use the Hyperledger Indy identity and the credential systems. So now come back to Hyperledger Indy. So basically, there's a conception called I mentioned before, the self-sovereign identity. There's a set of standards. Basically, there are 4 layers of the SSI standards. So it's coming from the very bottom. That's layer 1. That's the ledgers, which contain the DID and the public blockchain. And then on top of the layer 1, that's the layer 2 standard, or they call the agent-to-agent protocol, where the agent, the Indy agent, can connect with each other and then to communicate, to share the credentials and issue and verify. Actually, issue and verify the credential. So those 2 bottom layers are the identity meta system. So they are regulated or controlled by the machine, by the rules, without too much intervention of the human beings. And then the top part, the top 2 layers, more about human trust and the human kind of intervention in the self-sovereign identity ecosystem. The layer 3 is about the credential exchange. So you have those 3 issuers, holders, and the verifiers. Those are the real individuals, real companies. They need to before they can issue or verify the identity, they need to trust. They need to build the trust before using Indy to do the issuing and the verifying. And on top of very top, the governance layer on the Indy network, there are several roles. They call trust anchors, governance authorities, where they set up the permissions to who can write the credential schema on the blockchain, and who can issue the credentials. So those are more about human control put in place. Those are the top 2 layers. So there's those are the 4 layers of the SSN standard. Then I mentioned earlier that's the Hyperledger Indy network, or the sovereign network itself. It's also kind of a layered network. In the very core of the Indy network are the validator pool. Those are the you can think about those are the blockchain, Bitcoin or Ethereum node, where those nodes can have the read permission to read the data onto the ledger. The data I mentioned before, the DID, the schema, credential, definition, verification, registry. Those data are the validators read those data on the ledger, and then the observer pool. So the observer pool are read only. Those are the nodes can only read the data from the ledger without the writing permissions. And then the very outside layer, those are they called the cloud agents or the cloud wallets. Those are the think about like the decentralized application, DApp or DApp. In our case, the CrossPool, our CrossPool system. Those other systems can interact with the edge agents, like the mobile, people using mobile, or notepad, computer, laptop or desktop. The real user use those edge agents to connecting to the cloud agents, and then the cloud agents can enable the edge agents or the users to get credentials issued by another agent or by the agent itself, and also can verify the credentials saved locally in the mobile devices or laptops. So those are the layered communications among the agents and the validator pools of the Indy network itself. So the Hyperledger Indy itself is not a one application. Is a suite of tools and libraries. The very bottom here, there is I showed you the Hyperledger Ursa. That's the library. It's a cryptographic library. All the Hyperledger projects are using the Hyperledger Ursa for their cryptography features. Then on top of the Ursa, on the right-hand side, the blue boxes, the Indy node and the Indy Platinum projects. Those are the the GitHub projects. You can have a look, and then you can you can use a reference yourself. The blue boxes are for the Indy network, the ledger itself. So if you want to just run a Indy network, Indy ledger, you can download the software from the GitHub. And then on the left-hand side, the green boxes, the Indy agent and the Indy SDK. Those are the tools and the libraries. In our case, the CrossPool, we are using these to implement the Indy features, Indy functionalities, and to enable our tools or our application to communicate with the Indy network. So those tools, if you want to implement your own application with Hyperledger Indy, you can use those tools. So on the top, that's the github.com Hyperledger. You can go there. That's a whole bunch of GitHub repos. And then the very bottom, I prepared a kind of quick demo to show the basic credential issuance verification demo. You can go to my my GitHub repo Broccoli Indy Node.js demo to download and follow the instruction to run it, to have a real feeling about the Hyperledger Indy and how it works. Yeah, so that's all. That's it. And then these slides you can download it from my OneDrive share, and then all the references I listed in this slides. You can read you can read them later by yourself. And yeah, thanks for listening. And any questions? Okay.
So Charlie, it's Julian.
Yeah, hello, Chandra. Hi.
Hi. So how long have you been? You've now got this in production, right? What you're working.
Yeah.
So how's that? How long's that been going, and what kind of experiences have you had?
I think because of the volume, it's in production, but we don't have too much volume, to be honest. So far is it's okay. We issue, we have one issuers, and we did another two in the last couple of months. So we only have 3 issuers in terms of investors, not that much. So and also the Indy network we are running is actually we are holding the Indy ledger or in the Indy network itself. So we run like a 4 nodes Indy network, and all the credentials, all the data are all hosted on the AWS virtual machines. So the performance is okay. And then in the next phase, actually we are kind of engaging with Sovereign Foundation. So Sovereign Foundation, they are doing a public Indy network, Indy ledger. So that that's supposed to be shared globally. All the the credential schema data, definition data can be shared. So we intend to use that later. Then that will spare our efforts to run our system, the Indy node. So we don't need to go back to this one. So we don't need to run the validator pool, observer pool. Those will be hosted by the Sovereign Foundation. We just run our application. Yeah. So yeah. So far, because of the volume data is okay. Yeah.
Excellent.
Yeah.
Hi, Charlie. This is Casey.
Hello.
Hi. May I know if CrossPool is offered as a service or a piece of software that enterprise can use it? They own their own platform, or they have to use your existing platform?
No, it's a suite of software. So you can run yourself. As I explained to Julian, for the current one, we have come back. The links here. The app.crosspool.io is our current production. The kind of the beta version. That's all the services are hosted on AWS. And so if you prefer to run your own version of tokenization or digital asset issue platform, you can have the whole thing running by yourself. Yeah.
Okay, that means currently the app CrossPool is something just owned by yourself by FinFabrik and
Yes.
just run by yourself. Okay.
Yes.
But
exactly.
it's still, if an enterprise is looking for a whole solution, you still can offer this. Build everything on their premise.
Yes. So this is we have a software provider. We can provide the whole thing. You can either run in your own premises using here, say for example, the Indy network and Coda to have your own network, or you can join the public Indy network or public Coda network to share data globally. So it's all up to the the software or the whole platform owner to decide. Yeah.
I see. So CrossPool provide these options too.
Yes.
Okay.
Yeah.
Great. Thanks.
Yeah. No problem. And sorry, about someone asking about the file link. So here you can scan the QR code, or the links actually here. I'll copy the link to the chat room, so everyone can have that link.
So, Charlie, this is Ravi. A quick question. Hi.
Yep.
So, in terms of the commercial model, have you thought about how the transaction would be commercialized? I mean, how the solution would be business, viable from a commercial perspective?
Oh, you mean the CrossPool?
Yeah. Yeah.
Yeah, for the commercial, we just license the software, so it's kind of the license fee, and also depending on the negotiation, we could say, okay, just a small amount of license fee and the commission on the transactions you're gonna have in your platform, or you can have a big sum of license fee without any kind of the license the commission charged later. So it's all negotiable.
Yeah. So I mean, do you have even, let's say, the issuer onboarding fees, some kind of a fees for issuer onboarding, verifier onboarding, or is it just on the transaction cost?
Oh no, so that's I explained to Cassie, because we are a software provider, so we provide the software to the to the issuer, to the issuer. So the issuer, for example, if the issuer is a bank or is another company, they want to issue shares, or maybe this is a company of incubator, they want to issue the shares for their incubated projects. Then is the relationship between us and then the issuer. So we charge the issuer for the software license fee, and then for onboarding onboarding fees and verification fees. All the other fees are actually up to the issuer. So the issuer is actually our client. I don't know if you understand. We are not saying we are not a BaaS, so we are not providing blockchain as a service. So you just register on our system. We could do that, but now we just provide the whole suite of software to a potential issuer. Asset issuer, digital asset issuer. If the issuer is a company, banks, then they buy the whole thing. They will run by themselves. We can help them. We can help the client to run themselves, either as a clouding services or install software on premises. But then we only charge for the like a software license fee, and then all the other fees are just between the issuer and their own clients, investors. Yeah.
Got it. So in your solution, do you also provide the cloud agent, mobile agent, or this is mainly the Indian network?
We no, the network we can create. So let me go back to this one. So in here, I showed the Indy network and the Coda network. So it's those are optional. So if you want to totally host the two networks within your own, data center, that's an option as well. Or if you want to say configure the node to join the public Indy network and public Coda network is doable as well. So it's just a matter of configuration in the software package, and then obviously if you want to run the Indy network and the Coda network yourself, that will incur extra cost to you have to have the extra node running. Yeah.
Got it. That helps. Thank you so much.
Okay, no problem. I already pasted the file link in our chat, in the Zoom chat. So you can click and download the PDF slide. Hope that's gonna be helpful. Any other questions? Okay, so if no other questions, I think that's kind of that's it for today's sharing. Over to you, Cliff.
Okay, thanks, Charlie. Thanks everyone again for your time to join our Hyperledger Sydney up. So keep an eye on the Meetup page, and we are going to organize further meetups in 2020. Okay, thanks everyone, and have a nice evening. Bye.